given the general graph search algorithm, depending on which data structure we pass in, it'll have different behaviors as we traverse through the graph. So if we use a queue, then we'll perform breadth first search versus a stack. We can perform depth first search. And these are named accordingly because with a queue, if you think about trees, you'll end up doing level order traversal, or starting from some starting node, you'll do everything one step away, or the next level away. So you'll evaluate everything within one step. And then the next level you'll step out, and the next level, and the next level. So you can see that if we're searching for a goal, we actually expand out like ripples in a pond, and keep expanding out, and keep expanding out until we found our goal. So you can see that if we're searching for this goal here and starting here, that we're expanding a lot of vertices, and we're visiting a lot of we're traversing a lot of edges that we don't have to. So if somehow we can know that our goal is here, we shouldn't have to expand all of these edges. And then that's how DFS works. It's sort of a level order traversal within a graph. BFS works that way. DFS is going to use a stack, and you can think of it as from the starting node, take a step away. From that current position, take another step away. From that current position, take another step away. Take another step away. Take another step away. And you can see that you may, if you end up in a dead end, sort of like walking through a maze, if you end up in a dead end, you have to backtrack until you get another possibility. Okay? So maybe this depth first search, step away, 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 dead end. So I have to backtrack along this course, and then I find a new path that I can follow. And you can see that if we're lucky, it'll head towards our goal. If we're unlucky, it may end up somewhere off forever far away. So depth first search, where breadth first search is organized in its concentric circles expanding, depth first search sort of wanders around and goes everywhere, and eventually will end up where we want it to. Now, given an infinite graph, BFS will still always find the goal because it's searching levels outwards. Given an infinite graph, DFS might not. It'll only find the goal if we're lucky, because if you think about depth first search, it's trying to get far away. So what it's going to do is keep stepping away. And given an infinite graph, it may never come back, or it may head off in the wrong direction. But in general, if something is close, you want to use breadth first search. If it's further away but still a finite graph, you may get lucky with depth first search. If we talk about paths of how to get to the goal, so you can see here that even though I expanded and tried all these possibilities, I still found a direct path of how to get there. So step out a level, step out a level, step out a level, and I still found the fastest way to get here. So breadth first search is guaranteed to find the most efficient path from start node to goal node. It won't happen in the fastest amount of time because you're expanding extra stuff, but it will always give you the most efficient path, or the shortest path from start node to goal node. DFS, you can see by this example that it went everywhere and eventually found it. So it will find it, and it may find it faster than BFS, but it's not guaranteed to give you the shortest path between start and goal. And you can easily see that by this example here.